All right, welcome. Today we are going to crack the code on one of the most powerful and maybe one of the weirdest looking operations in all of math, matrix multiplication. I know, it can seem a little intimidating at first, but it is the secret engine behind some of the most amazing technology you use every single day. So let's get into it. I mean, have you ever really thought about that? How can a game character just run, jump, and spin around in this huge, complex 3D world, and it all happens instantly? Well, the answer, believe it or not, lies in the exact math we're about to break down. Stick around because you're about to see exactly how it's done. So here is the plan. First, we'll figure out what this weird math even is. Then we'll cover the super important rules of the game. After that, we'll roll up our sleeves and actually do the math step by step. Then I'll show you the 3 most common traps to avoid. And finally, we'll connect it all back to how those incredible 3D worlds get built. Okay, so first things first. What even is this? You probably know how to add matrices or maybe multiply one by a single number, but multiplying 2 matrices together, that is a whole different beast. It's a totally new way of combining them, and it unlocks some seriously incredible possibilities.
And really, our goal for today is simple. By the time we're done here, you are going to feel totally confident using what's called the row by column method. This is going to be our mantra, okay? It's the absolute key to getting this right every single time. Now, before you even think about doing a single calculation, there is a critical first step. It's like a bouncer at a club for matrices. You gotta check the dimensions first. Not all matrices are allowed to multiply, and there's one simple rule that decides who gets in. And this right here, this is the golden rule. If you've got a matrix A that's m rows by n columns and a matrix B that's p rows by q columns, you can only multiply them if those 2 inner numbers, n and p, are exactly the same. And here's the cool part. This rule also tells you the size of your answer. It's going to be the outer dimensions, m by q. All right, so once we're past the bouncer, we can actually start the math. And it's all in the name, row by column. You literally take a row from the first matrix and a column from the second. Then you do something called a dot product, which sounds fancy, but it's not. You just multiply the first numbers together, the second numbers together, and so on, and then you add all those little answers up. That one final number you get becomes a single spot in your new matrix. Then you just repeat. Okay, enough with the theory. Let's get our hands dirty and actually do the math. Talking about it is one thing, but actually seeing it in action is where it really starts to click. We'll take this nice and slow. Okay, here's our first patient on the operating table. 2 simple 2 by 2 matrices. First, the dimension check. A is 2 by 2, B is 2 by 2. The inner dimensions are 2 and 2, they match. We're good to go. And the outer dimensions tell us our answer will also be a 2 by 2 matrix. Perfect. All right, let's find that very first number, the one in the top left corner. Remember our mantra? Row by column. So we take the first row of A, which is 1, 2, and the first column of B, which is 5, 7. We multiply the first numbers. 1 times 5 is 5. Then the second numbers. 2 times 7 is 14. Add them together. 5 plus 14 gives us 19. Boom. First entry is done. So what about the spot next to it? First row, second column? Well, we keep using the first row from A, but now we grab the second column from B. So it's 1 times 6 plus 2 times 8. That's 6 plus 16, which is 22. You see the pattern, right? The position of the answer literally tells you which row and which column to grab. And if you keep that rhythm going, row by column for the bottom left, row by column for the bottom right, you end up with 43 and 50. And there it is, our final 2 by 2 matrix. That's the product of A and B. All right, let's try a different one, just to prove this works for any shape. Here, matrix A is a 2 by 3, and B is a 3 by 1. First, the check. Do the inner numbers match? Yep, 3 and 3. We're good. And what will the answer look like? It's going to be the outer numbers, a 2 by 1 matrix, just a tall, skinny one. So for that top number, we grab the first row of A and the only column of B. Multiply them up, 1 times 1 plus 2 times 2 plus 3 times 3, that gives us 14. For the bottom number, we use the second row of A and that same single column from B. So 4 times 1 plus 5 times 2 plus 6 times 3, which gives us 32. See? It's the exact same method. It doesn't matter what the shapes are. Okay, now that you've got the basic move down, let's talk about the traps. These are the places where people usually get tripped up, and knowing them ahead of time is going to save you so much frustration, trust me. All right, here are the top 3 mistakes people make. Number 1,
Just multiplying the numbers in the same spot, like you do with adding. You gotta resist that urge. It is always, always row by column. Number 2, just jumping in without checking the dimensions. You might start a problem that's literally impossible to solve. And number 3, well, this is the biggest trap of all. And that brings us to the biggest one, the one that gets everyone at first. With regular numbers, we all know 3 times 5 is the same as 5 times 3. With matrices, that is not true at all. The order you multiply in is absolutely critical. A times B is almost never, ever the same as B times A. Order matters. And if you don't believe me, just look at this. It's undeniable. On the left, we do A times B with these simple matrices and get an answer with a 1 in the top corner. But on the right, when we flip the order and do B times A, we get the 0 matrix. Totally different answers. Case closed. Okay, so let's circle all the way back to the beginning. Video games. We've learned the rules, we've done the math, so why should you care about any of this outside of a math class? Well, it turns out this weird math is the secret sauce behind every game you play. I mean, seriously, just take a second and let that number sink in. Billions, with a B, every single second. Your computer's graphics processing unit, the GPU, its whole job is basically to be a super fast, specialized matrix multiplication machine. That's how fundamental this one single operation is. So here's the secret. In computer graphics, every single thing you can do to an object, rotate it, shrink it, move it across the screen, is represented by a matrix. And what if you want to do 2 things at once, like rotate and move a character? You just multiply their matrices. The result is one new, combined matrix that does both actions at the same time. So the next time you see a character in a game moving around so smoothly, what you're really seeing is the result of a crazy, non-stop stream of matrix multiplications, blending all those tiny movements together. So yeah, mastering this row by column thing, it's literally the first step to understanding the code that builds these incredible virtual worlds. And that kind of leaves us with a final thought, doesn't it? We just saw how this one simple-looking operation is the absolute backbone for building entire digital worlds. It just makes you wonder, what other mathematical secrets are hiding in plain sight, quietly powering the technology we use every single day?